Here in this video, we are solving two questions that were given in NEET 2020 as well as NEET 2021 from a chapter Nuclei of the second year plus 2. Let us read what the question is. A radioactive nucleus IGCSE undergoes spontaneous decay in the sequence from this to this, this to this, then where Z is the atomic number and X is the element. The possible decay of the particles is what? What are the particles that were got decayed is the kind of a question that is being asked, right? So, to understand that, let us see what happens in the radioactivity so that you will be able to identify the answer. You know, a heavy nucleus like radium, thorium emits rays from their nucleus called alpha, beta and gamma rays. So, when alpha particle is emitted, what happens? Let us try to understand. When alpha particle is emitted from the nucleus, say IGCSE, from that an alpha particle is emitted. Alpha particle is somebody that have a atomic number 2, mass number 4. Means what? It's an emission of 2 protons with two neutrons. So, what happens is, that is an atomic number. As 2 protons were lost in the given nucleus, that X becomes X of Z becomes Z minus 2. And A is the mass number. As 2 protons and 2 neutrons are lost, total mass approximately 2 plus 2, 4 is lost, assuming that the mass of the neutron and proton is approximately same. This is what happens when an alpha particle is emitted. Now, when a beta particle is emitted, what do you mean by beta particle emission? Is actually within the nucleus there is neutron, that is N01. This neutron gets converted into inside the nucleus as a proton as well as a. So, when a beta particle emitted means the nucleus, a neutron inside the nucleus is converted into a proton as well as a electron, and of course some kind of an antineutrino, all that is released to balance the extra mass that is available. So, what happens in this case is its mass number is not going to be affected because there is one neutron that is converted into proton. So, mass number is balanced. But what happens is neutron is not having a charge, but proton is having a positive charge. So, what happens at an output level is its charge means its atomic number increases by 1, its charge increases by 1, right. So, what happens is IGCSE when a beta is emitted becomes A remains same, but Z becomes Z plus 1. This kind of a beta is actually many times called something like beta minus, right. But there is another kind of possibility for the beta emission where people call it like as a beta plus emission from the nucleus. This is another possibility. What happens in the case of the beta plus is the proton inside the nucleus is getting converted into a neutron and an electron. Of course, some kind of an antineutrino that is also released anyway. So, what happens in this case is the number of the protons after this beta plus emission is reduced by 1. Number of the protons is reduced by 1. Whereas as the proton is converted into neutron, its mass number remains the same. So, in this case IGCSE when the kind of beta plus is emitted, what happens is Z becomes Z minus 1 because one proton is lost in this case, and A remains the same. And there is one more possibility, that is emission of the gamma radiation. When alpha or beta radiation happens, these elements will go to a kind of a higher level excited state, and they return back to their original positions. When they are coming back to their original positions, they will emit some kind of energy, and that emitted energy is in the format of a gamma radiation. So when gamma radiation happens, it's only the energy that affects, neither Z nor A gets affected. Z and A remains the same. This is what happens when alpha, beta and gamma radiations are happened. Taking that into consideration, look at the question, right? Z became Z minus 1. Z becomes Z minus 1 when what emitted out is beta plus. So here in the first case, what emitted is beta plus. So there is only one option starting with beta plus C, and that's only the answer. Further you see, Z minus 1 has become Z minus 3, that means that is reduced by 2, that is atomic number. Atomic number will be reduced by 2 when an alpha particle is emitted, right? Further what we can see is, next Z minus 3 has become Z minus 2, that means this is increased by 1, atomic number is increased by 1. Atomic number is increased by 1 only when beta minus is emitted. So here what is emitted is beta minus. So you need to know these basics, or while solving this question you learn these basics. Right, look at the next question. What happens to the mass number and atomic number of element when emitted gamma rays? I already told you, atomic and mass number remains same when there is an emission of gamma state, because after emission of alpha and beta, these excited elements comes back to their normal state. In the process they emit energy. That energy is gamma rays. They don't have any charge. They are neutral. They are pure energy particles. That's how we can solve this problem. Thank you for watching.